Hello, my wonderful students. Today we are going to be looking extensively at the topic laws of indices. Okay, it's going to be very interesting. Now, indices is actually from the word index. Now, indices is actually from the word index, okay? Where indices is the plural of the word index. Now, what is index form of number? Okay, index form of numbers. Hmm? Now, a number is said to be in an index form if it assumes the format a raised to power n. That is a number in index form. Okay, this is index form of number. Now, where this a is actually the base in this case, then the n is actually the power in this case. So any number that can be written in this form is known as a number in index form. Now let's see some examples of numbers in index form. So check it below. Okay, below is the table of examples. Now I have 4. Do you know that this 4 can actually be 2 times 2? And how many of the 2's? We have 2 of them. So this is actually 2 raised to power 2. That is, the index form is 2 raised to power 2. Remember the form, index form, okay? So this, if you check, the base here is 2 and the power is still 2. Now let's come back to 32. Now what seems to be the case in this 32 is, what is that particular number that can multiply itself to some certain amount that will give you 32? Okay, it is 2. And it is 2 up to 5 times. That is 2 raised to power 5. If you multiply 2 up to 5 times, you will get 32. The base is still 2 and the power in this case is 5. Now look at 81. I know that 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So it's going to be 3 raised to power 4. And the base is 3 and the power is 4. Then another move, of course, 100 is very simple to know. That is 10 times 10. So just 2 of them, 10 raised to power 2. Then the base is 10 and the power is 2. Now look at 125. As long as I have 5 behind, I know that 3 is there, 5 is there, possibilities, okay? So in this case, it is 5. This is going to be 5 raised to power 3. Then the base is 5, the power is 3. Then I have 243. Now 243 is actually 7 raised to power 3. All right, so the base is 7 and the power is 3. So basically this is an example of numbers and their index form, okay? Spelling out or showing out the base and the power. Now, you know, we are talking about the laws of indices. Now, since we actually understood the concept of index numbers, so let's see, what are those laws? What are those rules that actually guide numbers in index form, which simply implies laws of indices? So what are those rules? We'll go into the rules now. So I want you to be patient and follow to really understand what the rules or what the laws of indices actually entails. Okay, the first to be discussed will be the multiplication law. Now, what is this multiplication law all about? What is it all about? Now, multiplication law, this states that if I have an index number x raised to power n, then times another index number x raised to power m, it implies that the answer will be x raised to power m plus m. Now, the summary of it is this. Once their bases are the same, okay, and they are actually multiplying, then you sum their powers. So this is what it is. Now, example, we'll start with the first one. If I have 2 raised to power 2 times 2 raised to power 3, my answer will be, since the check out the base are the same, 2, then it's going to be 2 plus 3. So the answer is 2 raised to power 5. That is what it is. Then another example, example 2, if I have 3 raised to power 2 times 3 raised to power minus 3. If I have something like this, then the answer is going to be 3, because the bases are the same. Then is we are going to have 2, then plus, good, because it is multiplication, that is why you are adding the powers now. But this power for the second index number is minus 3, so we are going to have 3 raised to power 2 minus 3, and the answer is going to be 3 raised to power minus 1. So we are done on that note. Now, another thing that I want you to take note is this, from this third question. If, for example, I have 4 times, let's say, 2 raised to power 2. Now, you see, sometimes students get confused. You like, okay, the first one is just 4, it's not an index number, and we are talking about laws of indices. What will happen? See what you need to do. Make sure you check if you can actually write it in index form. Yes, I can write this 4 in index form, which is 2 raised to power 2, then times 2 raised to power 2. And my answer based on this multiplication law is going to be 2 raised to power 2 plus 2, because now their bases are the same. So you now add the powers, and the answer is going to be 2 raised to power 4. So we are done on that. So we are through with the first multiplication law. Then the second thing we are going to be looking at is division law. So two, now division law. Now what happens in this case is, if I have x, let's say, raised to power n divided by x raised to power m. Now check out, the bases are the same, both x. What is going to happen now is going to be x raised to power n minus m. This is what the law says. Okay, recall, when it is multiplication, you add the powers, and when it is division, you actually subtract the powers. Now, the same, we can have examples, okay, e.g., number 1, we can have, let me say, 3 raised to power 2 divided by 3 raised to power 4. Once you have something like this, it means it's going to be 3 raised to power 4. Because of this division, raised to power 2, not 4. Okay, raised to power 2 first. Then because of this division, you have minus, then 4. So the answer is going to be 3 raised to power minus 2, because 2 minus 4 is minus 2. Now, another example is this. What about if I have 5 raised to power 1 divided by 5 raised to power minus 2? What will happen? Okay, now this is going to be 5 raised to power 1, all right, then minus, because of the division, but remember I have 2 already, so minus 2 already, so it's going to be like that. And the final answer is going to be 5 raised to power 1 minus this minus times this minus becomes plus 2, so the answer is 5 raised to power 3. All right, so we are done with the second law. Then let's move to the third law. The third thing I'm going to be looking at is going to be indices with brackets. Okay, indices with brackets. Now, under these indices with brackets, I'm going to be looking at this. The first is, let me pick this A. The first says, if I have x raised to power n, then the same index number is raised to another power m. What seems to be the case is going to be x raised to power n times m, which is x raised to power n m. That is what it is. Now, an example under this is, if I have 2 raised to power 3 or raised to power 2, like this. So my answer is going to be 2 raised to power 3 times 2. The answer is 2 raised to power 6. The same thing if I have 3 raised to power minus 1 or raised to power minus 2, is going to be 2 raised to power minus 1 times minus 2, and it's going to be 2 raised to power plus 2. So this is the answer. So this is what it entails. Then let me get to the B under this law. Now, if I have x, y, then z, all these factors raised to power n, then my answer will become x raised to power n, y raised to power n, and z raised to power n. Okay, all of them will have that power n. In fact, if I have x over y, all raised to power n, is still x raised to power n over y raised to power n, right? So let me give you an example to see. If I have, let's say I have a raised to power 2, b raised to power minus 1, and c all raised to power 3. Now, combining what I've taught you under these indices with brackets, now this will be a raised to power 2, then raised to power 3 because of this power 3 here. Then I have b raised to power minus 1 raised to power 3. Then I have c, I have raised to power 3. Now, this, the first one becomes, from the law, becomes a raised to power 6, and I have b raised to power minus 3, then I have c. Okay, so take note, you can actually have this in like this. So quickly, let's move to the next law. The next law is negative indices. Okay, that's the fourth one. So we are looking at negative indices. Okay, now you see, this is very important. Let me start with this. If I have, or it says that x raised to power minus n is equals to 1 over x raised to power n. But I need to explain this so that you understand. How do I come about this? Okay, watch. X itself is the same thing as x over 1. All right. Now, once you have a negative, the rule is that if I have x raised to power n like this, to take off this negative, then this fraction will be reciprocated. Okay, we find the reciprocal of this fraction, that is the denominator we move to the numerator and numerator to the denominator. Hence, we are going to have 1 over x all raised to power positive n now. Okay, now remember we just discussed this not long ago. Okay, indices with brackets. Now, do you know that this is the same thing as saying 1 raised to power n all over x raised to power n? But you will agree with me that 1 times 1, no matter the number of times, is still what? 1. So we still have 1 over x raised to power n. So this explanation is very important. Okay, especially can be seen in this. What about this? If I have x over y or raised to power minus n, what will happen? Now you need to understand that you can just have that knowledge that for the negative to go, just interchange the numerator and the denominator, so that you're going to have y over x all raised to power positive n, and this is going to be y raised to power n over x raised to power n. So it is very important you can know this. Okay, then let's go and get some examples now. All right, to actually explain what I have taught you. The first example, number 1, let's say I have 1 over 2 or raised to power minus 2. Now recall, because of this negative, is going to be 2 over 1 or raised to power 2, which is the same thing as 2 raised to power 2, and the answer is 4. Very simple, and short. Now let's go to example 2. Okay, example 2. Let's say I have 2 over 3 or raised to power minus 3. Now, because of this minus, it becomes 3 over 2 raised to power positive 3. And this is going to be 3 raised to power 3 over 2 raised to power 3. 3 raised to power 3 is 27 over 3 raised to power, this is 8. All right. So how many times will 8 go into 27? Got to be 3 times. Then remember 3 over what? 8. So you see, you can actually do this. It's very simple. It's not hard. All right. Then let's move to the next law. I think we've done the fourth, now the fifth. This is very important, okay? So we have fractional indices. Now, the first thing we're going to be looking at these fractional indices will be the roots. Now, what do I mean? This is what it is. If I have x raised to power 1 over n, it means it is the nth root of x. Very simple and short. Now, example, if I have 4 raised to power 1 over 2, then I'll check. This is going to be the square root, okay? There's no need of me writing 2 here. No need at all, okay? Because we know the standard sign for square root. So, x in this case, not x, is 4, and the answer is 2. Now, if I have 8 raised to power 1 over 3, do you know what that means? It means it is cube root of 8. And cube root of 8 is 2. If I have, for example, I have 128 all raised to power 1 over 7, it means it is the 7th root of 128, and it's still 2. If I have 125 raised to power 1 over 3, it means it is the cube root of 125, and the answer is 5. So this is all about roots. All right. So you take note of roots. Very important. All right. The next thing I'll be talking about under this, that is the B, is this rule. If, for instance, I have x raised to power n over m, how can I, or what will I do to actually work this out? Do you know that this can actually be written from the laws we've discussed above, can be written as x raised to power 1 over m times n? Yes, I can write it this way. All right. Hence, it is like saying the mth root of x all raised to power n. That is what it is. As simple as that. And you see from example, you see what it means. Now, let's say example, e.g., the first one, let's say I have 8 over 27 all raised to power minus 2 over 3. What will be the case? I'm going to combine some things here now. Now, watch. Because of this minus, do you know the numerator and denominator will change, so that I'm going to have 27 over 8. Good. Then I have 2 over 3. Now, because of this base of the fraction, this 3, okay, it will now be that I'm looking for the cube root of 27 over 8. Then, because of these 2, it is all squared. All right. Now, what is the cube root of 27? Cube root of 27 is 3, and cube root of 8 is 2, all squared. And this is going to be 9 over 4, which is going to be 2 whole number 1 over 4. It's as simple as that. We're done. We're good. Now, listen. Sometimes you can, instead of writing it this way, you can actually write it as cube root of 27 over 8 all squared. Is still the same thing. The same thing with this, it will give you the same answer. So don't feel like, okay, it's going to give you a different answer, or maybe you see it in some other literatures. Don't feel it is wrong. It is actually very correct. The next, which is actually the last one we are going to be looking at, that should be 7. Is it 7 or 6th? Let me check. Okay, that is the 6th. Is power of 0. This is actually very simple. It says as far as x is raised to power 0, the answer is 1. So it doesn't matter if it is 2 raised to power 0, the answer is still 1. If it is 1 million raised to power 0, the answer is still 1. Whatever it is raised to power 0, even if it is decimal raised to power 0, the answer is still 1. So that is what this particular law is saying. Okay, before we go, I want to like challenge you with some questions. Okay, I have some questions. I want to actually work them out. I want you to follow it. Okay. Um, Further examples. Now I have the first one. I have 2x y squared z raised to power minus 3 times 3x raised to power minus 2, then y and z raised to power minus 1. What about if I have a question like this? What will I do? Now, this is what I want you to do. It's as simple as this. Pick the terms and work them. Okay, pick like terms and work them. See what I'm talking about. You see this 2 and this 3, they are just normal numbers, so I have 2 times 3. I'll keep it. Then I'll go with y times the other y here is y raised to power minus 2. I keep it. Then I pick z raised to power minus 3, then times z raised to power minus 1. I have it this way. Once you do it this way, it becomes very easy. You can actually easily apply the law. So 2 times 3, of course, is 6. Then this is going to be x raised to power 1, because this is actually raised to power 1. It's just 1x there, okay? Then plus we have minus 2. I have it this way. Then I have z raised to power minus 3, then plus minus 1. I have it this way. So this is going to be 6, and this is going to be x raised to power minus 1. And I have z raised to power minus 4. You see, I'm done. This is the answer. Once you just group them, you will get your answer easily. Okay, then let's go to another example. What about if I have 15a squared b raised to power minus 3, then c divided by 3a and b raised to power minus 2? What will happen in this case? The same way we group, that is exactly what we are going to do here. We are going to group it. Now I have 15, okay, divided by 3. I have grouped this. Then I pick a raised to power 2, and I pick this other a here, which is divided by a. I have it. Then I have b raised to power minus 3 divided by this b raised to power minus 2. Of course, the last one is c, and c doesn't have anything, doesn't have any other c on the other side. So we are done. We are okay. Then we move. 15 divided by 3, this is going to be 5. So I'm done with this part. Then this is going to be a2. Then because of this division, it's going to be minus 1. Okay, because this is like a raised to power 1. Then I have b raised to power minus 3 minus then minus 2. Okay, then I have my c like this. So this is going to be 5. Then this is a. Then I have b. You see, I have minus 3. Then minus times minus 2, we have plus 2. So it's going to be minus 1. Then I have my c. Very simple. That is it. Then let me give you this. The example 3 now. Okay. What about if I have all root of 80 a raised to power minus 2, then b raised to power 2, and c all over. I have 5 a raised to power 4, then b raised to power minus 2, and c raised to power 3. What will happen in this case? Now, the first thing I need you to know is this. This is the same thing as writing 80 a raised to power minus 2, b raised to power 2, c all over 5 a raised to power 4, b raised to power minus 2, then c raised to power 3, everything raised to power 1 over 2. Remember that root when we talked about fraction law. So that is where it plays now. Now, just as we grouped our work in these previous examples, the same thing is going to happen here. Do you know I can have 80 over 5? I'm grouping it now. All right. Then I have a raised to power minus 2 over a raised to power 4. Then I have b raised to power 2 over b raised to power minus 2. I'm grouping it. Then I have c over c raised to power 3. Good, I've done that. Remember, everything is actually what? raised to power 1 over 2. Okay, good. Now I move. I'm going to have 80 divided by 5. That is what it means. Then I have a raised to power minus 2 divided by a raised to power 4. Then I have b raised to power 2 divided by b raised to power minus 2. Then I have c divided by c raised to power 3. Okay, this is going to be 16. I have this. Do you know this is going to be a raised to power minus 2? Then it's going to be minus, okay, minus 4. Good. Then I have b raised to power 2, then plus 2. I think I've shown you what is happening already in the previous example, so I think it's not going to be a problem for me to make this conclusion. Then I have c raised to power 1 minus 3. Okay, my final answer on this note. Remember, everything, don't forget, is raised to power 2. Okay, raised to power 1 over 2, raised to power half here. The same thing here, so it's going to be 16, a raised to power minus 6. Then I have b raised to power 4. Then I have c raised to power minus 2. Everything is raised to power what? Half. Now remember that law that we talked about, indices in brackets, is going to play here. Now this is going to be 16 raised to power 1 over 2. Okay. Then I have a raised to power minus 6 raised to power 1 over 2. Then I have b raised to power 4 raised to power 1 over 2. Then I have c raised to power minus 2 raised to power what? 1 over 2. All right. Now, remember the root law. It's going to play a part here in the first thing. 16 raised to power half is 4. Then, remember, still that law of brackets. 2 times this is going to be a raised to power minus 3. Good. Then can you see that this will cancel this out? So that it's going to be what? B raised to power 2. Then these 2, we go with this, is going to be c raised to power minus 1. So I've gotten my answer, which is very correct. Now some people can decide they don't want to leave it this way. They can leave, your answer can be in this form too. This is going to be, remember that negative law? Okay, I'm going to make use of it now. Then this is going to be 1 over a raised to power 3. Good. Then I have b raised to power 2. Then I have 1 over c. Okay. Now keeping it is going to be 4b squared all over a cube c. You can actually have your answer like this in this form too. So this is actually a very good basic explanation of indices. I'm going to be working on exponential indices in the next video. So keep watching and make sure you learn, and do not forget to subscribe. Thank you for being here, and thank you for